Okay. So I'm looking at this stuff. What did you come out with? What was your position on problem solving as it relates to technology? And did I ask you for an example? Oh, I asked you to tell me, give some direction as to when you should choose to write a new tool, create a new tool, versus use an existing tool. So what's our feeling on that? What did we come up with?
It depends on the gravity of the problem
The
and
gravity of the problem? I like that word. Okay.
and the number of people involved. I mean, the number of people involved, and whether the company is big enough to take a decision to build new tools, because it involves maintenance, testing, and all other costs. So if the institution is making enough profits, and if it's really affecting a lot of people and a lot of procedures, then definitely it's recommended they can do their own tools to solve the problem.
Okay. Well, so you said that the company is big enough. I'm assuming you mean so they could afford to pay to have a custom tool made. Well, let's assume that all companies can afford to do it. At what point is it the correct solution as opposed to using something that's pre-built?
Okay, if the existing tools, after evaluating to use the existing tools to a full potential, and if it still doesn't suit the business processes, at that point they have to go ahead, because they can't change the business processes to match the existing tool. So in that case, they have to go and build their own like tool.
Okay. So that would be the generalistic case when a tool doesn't match up to how they do things. Okay, what if a tool does match up to the way they do things, but the tool does, let's say they need to do five different things, and let's say the tool does four of them, and then the tool also does 10 other things that they don't currently do. At what point do they write their own version of the tool versus decide that the four things it does are the most important things? Let's say they'd like it to do five things, but the four things it does are the most important, and the fifth thing maybe isn't the end of the world. So, what's that litmus test for deciding whether or not an existing tool is the correct tool or building a new one is the correct tool? Take it a step further and say, let's say that a tool that you need needs to do five things. Let's say the tool does all five things, but let's say it does an additional 200 things. Excel would be a good example of this, right? Excel solves zillions of problems, but most people who use Excel need it for like a couple of little things, right? Why do we use Excel rather than build a tool that's specifically made for those problems that we're trying to solve? Why choose to use Excel in that situation?
In my industry, we're often reversed. We see people try to use Excel and find out that it doesn't work well. And a lot of times it boils down to more or less a time or an efficiency thing. If there are people who are spending hours and hours and hours every month trying to do the same things that the custom tool can do much quicker outside of the actual time it takes to develop that tool, it saves them money, it saves them time to do something else.
Okay.
They can have a smaller workforce or
So potentially, if the problem they're solving is a problem that's going to need to be solved for a while,
yeah.
even if it costs additional time and money now, it'll save time and money later. And at some point it pays for itself and then some, right? So that's a reasonable argument. So along those lines, you can make an argument that it depends on how complex and how maybe important the solution is. If it's something like, for instance, a good example that comes to mind is here on campus. We're supposed to take attendance in our undergraduate classes. I don't. It's inconvenient to take attendance. We don't have a true attendance taking solution online. What we're supposed to do is we're supposed to go into Banner, where we enter our final grades. We're supposed to go into the screen for final grades, and we're supposed to mark absences in the optional box for final grades, and then save that. That's the way we're tracking attendance. That's stupid.
We changed all
Huh?
that. We changed all that this past year.
Well, I've never taken attendance, so how do I do it now? I got yelled at by my dean the other day.
There's a class list picture of your class.
Yeah.
Everybody there, and you check the check mark at the top that says yes, everybody was here for the day, and you save it.
Are you serious?
Yep.
When were they going to tell faculty that?
They did tell us that.
When?
It's been in every email.
Oh, no. When are they going to tell faculty that? Who did that email come from?
Whoever's in charge of registrar.
If it was registrar, if it came from Steve Montreal, I might read it. But if it didn't, if it just came from random registrar,
No, it's not from like the registrar worker. It's from the head of the department. So if that's
well, that's Steve Montreal. I read most things that come from him. I delete. I actually have a rule in my inbox that if it's from @cuw.edu, it goes to spam. Oh no, actually, if it's to CUW all, it goes to spam. Yeah, I don't want crap.
no, it's in his email that he sends out at the beginning of every
It's
semester.
garbage. So you're saying there is a good solution now?
I'm not saying it's good, but it's better.
There's a
than it
better
was.
solution.
Yes.
So, well, okay, so it's still a good example. So at some point you guys decided that the old solution was dumb and we needed a more custom attendance solution. The problem always was that Banner is the tool the university chose for management, for managing our registration and all this other stuff. Well, so anything that we did had to work within the world of Banner, the rules that Banner set up. Well, they decided for a long time that the easiest solution to take attendance is to take attendance in your final grade screen or whatever, which, it just seems like a waste of time. But, all right, well, thank you for the information. I probably will not do it. But now I can't claim ignorance. I can claim obstinance. Right, that's a word, right? It's a real word. Okay, so something along those lines for the homework assignment was reasonable. Now let's, for the report, let's talk about the homework assignment. So I assume everybody found this trivial? All parts? So we don't even need to go over it? All right, so let's look at these individual parts. So the first one, so we're supposed to write a bunch of methods. First method said we're supposed to create a method called print vowels. This method should take a string as a parameter and print all the vowels contained in that string, one character per line. Okay. Okay. We'll get rid of all this crap. All right, so we want to create a static method. And just as a quick reminder, have we talked about class methods versus instance methods? Or we just introduced class methods? Talked about instance methods, but haven't written our own. We talked about them in terms of strings. Okay, got it. All right, so we're going to say static void print vowels. And this guy's going to take a string as a parameter, right? And what do we want to do? We want to print out all the vowels that are in that string. Okay, so this is a string. A string is a collection of 0 or more characters. We want to print out all of the characters in that string that are vowels. Okay? Well, I say 1 per line. That was the assignment said. 1 character per line. Okay? So, one thing we can do. First of all, we want to talk about solution patterns, programming patterns. So, I need to go through this string and look at each character. Whenever I need to go through a string and look at every character, I'm going to have a loop, and it's pretty much going to always be the same loop. For int I is equal to 0, I is less than s dot length, I plus plus. Okay? So this will take I on a journey through all the indices of s. And then how do we access an individual bucket of a string? How do we get the character at a specific bucket in a string? Not rhetorical. What method do I use to get the character at a specific bucket in a string? Char@. Okay? So each time through here, in order to get the current character, I'll say s.char@I. And this will boil down to the character at the current bucket. So one thing we can do is we can create a char C. And maybe we say C is equal to the current character, the character at bucket s.char@I. Then we can ask the question, if C is equal to an A, or C is equal to an E, or C is equal to an I, or it's equal to an O, or it's equal to a U. Yep. Or it's equal to an A, or it's equal to an E, or it's equal to an I, or it's equal to an O, or it's equal to a U. If any of those things are true, system.out.println C. That makes sense? So we'll test that. String S is equal to hello. Then we'll say this is a class method, right? How do you know? Static. How do we call class methods? Use the name of the class in which the method was defined. So I'll say driver dot print vowels, and I'll pass it my string S. And this guy should print out only the vowels in S, E, and O. Okay? How many people solved the problem this way? How many people solved the problem in a better way? Static void print vowels. We'll call this print vowels 2. Take a string S as a parameter. I'm going to create a quick string here, A, E, I, O, U, A, E, I, O, U. Okay, so here's an alternate solution. Just real quick, let's test it. Print vowels 2. Same output. So what did we do? I created a string name map. Call it whatever you want, but I called it map. And within this string, I put all the vowels. A-E-I-O-U, A-E-I-O-U in all caps. Then, my same programming pattern to loop through every character in S. I write the loop for int I equals 0, I is less than s.length, I plus plus. Each time, I call the index of method. I harped on this last class. Here's the index of method. The index of method does what? We have 2 of these. What's it called when you have 2 methods with the same name but a different number and or type of parameter? Polymorphism. Okay, so how does the index of method work? Ish. How does index of work? It's an instance method, first of all. If these are the method definitions, how do you know it's an instance method? No static. We know it's an instance method because there's no static. How do we call instance methods? Using an instance of the class in which the method was defined. We call class methods using the name of the class in which the method was defined. We call instance methods using an instance of the class in which the method was defined. This method was defined inside the string class, so we need an instance of the string class in order to call this method. Okay? Name of the method is index of. What does it do? Or does it just sit there and look pretty? I distinctly last class remember bringing up things like, I said, hint, hint, and very important that you recognize this certain aspect of index of. Index of takes either a char or a string as a parameter, and it returns the index of the first occurrence of that char or string in the calling string. Or what? What was that most important thing I told you to remember? -1 in the event that it does not find it. So what did I do out here? I created a string containing only the vowels. And since this guy is a string, he can call the index of method. So each time through, I'm saying map, call your index of method, pass it the current character that we're reading from the string. If it is not a vowel, or rather, I'm sorry, if it's not in there, we'll print it. Are we supposed to print vowels? Are we supposed to print vowels or print non-vowels? Okay, so this does not print vowels. This prints non-vowels, right? So if I pass it, this should print out EO. Same thing with this. So both of these are print non-vowels. If I want to change this guy to print vowels, I would just say only print the crap. So we'll go through all the vowels. If the current character I'm looking at is one of those guys, we'll print it. If it's not one of those guys, that is, it is equal to -1, then we'll print it. So not a vowel, print out all the vowels, or print out all the non-vowels. So this guy right now prints out non-vowels. This says the string of vowels, if I look up s.charat in that string and I get something that's -1, meaning I did not find the current character, that means the current character is not a vowel. Because I did not find him in there. So since he's not a vowel, I'll print him out. That's non-vowels.
Then you might end up printing out numbers.
Huh? No, that's fine. They're not, numbers are non-vowels. Is that a true statement? Aren't numbers not vowels?
Yes.
Okay. So to print out the actual vowels, not equal to -1, which means I did find it in there. So this will print out all the vowels. As I go through every character of my string, s.char at I, each time through I ask the question, is that guy not found in the string of vowels? When it equals -1, that means it did not find it in there. If I said it's not equal to -1, that means I did find it in there. So saying not equal to -1 is the same thing as saying greater than or equal to 0. I found it somewhere in there. Therefore, since the character I was looking for was somewhere in the string map, go ahead and print it because that guy was a vowel. Okay, so print vowels should print out all of the vowels. Hold on a second. Not equal to -1. That prints out just our vowels. Print non-vowels. Just have to change that one piece. Oh, I renamed it to non-vowels. Print non-vowels. Prints out everything but the E and the O. All the non-vowels. And all you had to change in there was this piece right here, if you used index of. Equal to -1 means the character we were just looking at was not found in the string we called the index of method with. Not a vowel. Print it out. Not equal to -1 means the character we're looking at was found inside the string we called. Therefore, he is a vowel. Print him out for print vowels. That make sense? So if I'm going to give you both versions, right now it is print non-vowels. The print vowels version of this guy we'll just call it print vowels 2 so they match up. So here's print vowels and here's print non-vowels using index of. Now, as an example of how index of works, if I say map.index of A, like that. If I type in that, what will the output be? It'll be 0. Strings are indexed from bucket 0. So A is found at bucket 0. E is found at bucket 1. W is found where? -1. Not found. So map.index of W says this guy is not a vowel because he boils down to a -1 when calling index of. That make sense? So index of is a power tool that would have come in handy in these first couple of methods of our assignment. Now, there's nothing wrong with this version down here, except what if I had done, let's say I had asked the same thing, actually maybe I did. What were the other questions? I do print consonants? Print consonants. That one must have sucked. You had to write out a bunch of OR statements for every single consonant in the entire alphabet. How'd you do print consonants? Sure, any of you. So let's look at print consonants. Did I spell that right? Where? Here? That. All right. So, how'd you do this one?
Print vowels.
Oh, you did non-vowels? Okay, well then you're back to what she said. You'd have numbers. Aren't numbers non-vowels?
Yes.
Are numbers consonants? Numbers are not consonants.
I did it the same way as the original sample you put up there, except I made it an if-else statement so that if it found it to be a vowel, it didn't do anything, and then if it found that it was not a vowel, it went out and printed it.
Okay, so yours would print numbers out too.
No, it didn't print numbers out. Did you type any numbers in your?
Yeah, it would have printed numbers.
Okay.
So like if we say print non-vowels, let's say I call this guy. Well, actually, it's currently set up to print vowels, this original version. And we call print non-vowels 2. Print non-vowels 2. He currently prints out all the non-vowels, but these are not the consonants. The consonants are HLL. 1, 2, and 3 are not consonants. Does that make sense? So if you were to do a, like the original thing, a bunch of else ifs, you know, if it's an A, if it's a E, I, O, U, blah, 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 else, if it's any of those, do nothing, else print out whatever the character is, right? Well, a 1 would not be an A, E, I, O, U in upper or lowercase, so yours would have printed out a 1 from the way you're describing it. Okay, so if we actually wanted to work for consonants, well, we can go through and write an epic if statement that checks every single consonant in upper and lowercase in the entire alphabet. But we probably don't want to do that, right? Okay, did I show you? Doesn't look like it. Okay. So I'm going to say string map is equal to, I'm going to start off with just writing the entire alphabet. And I'm going to write the uppercase version of the alphabet. Okay. Now I'm going to go through, I'm going to remove all the vowels. So there's my A, E, I, O, and U. A, E, I, O, U. So would you agree that right now string map is the string containing all of the consonants? That's what that guy is right now, right? So for print consonants, we're going to say for int I is equal to 0. I is less than s dot length. I plus plus. This will same exact pattern to go through every element of a string. We'll say if map dot index of s dot char at I, if that particular character is found inside of map, that is, it is not equal to -1. It's something that's not -1. It's a 0 or more. Okay? If it is found, then we'll print out s dot char at I. Otherwise, we skip it because it's not one of those guys. So that'll ignore vowels, it'll ignore numbers, it'll ignore punctuation. Make sense? So understand the difference here. If I print out non-vowels of this guy, I get the HLL123. If I print out consonants on that guy, I should just get the HLL. Here's the print consonants, HLL, but here's the print non-vowels. Understand the difference? All right. So print vowels, print consonants, print digits. Again, exact same pattern. Static, void, print, digits, string S. String map is equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. For int I is equal to 0. I is less than s dot length. I plus plus. What are we going to do each time? We're going to ask the question. If map dot index of s dot char at I, if that guy is not equal to -1, what am I going to do? System.out.println s dot char at I. So to test that, we'll say driver dot print digits, pass it s, so this should just print out the 1, 2, 3. There's my 1, 2, 3. Does that make sense? How our print digits, print consonants, and print vowels are all literally the exact same solution, with the only difference being what string map holds. So we've seen two patterns here. One pattern is the for loop pattern for looping through every character in a string. You'll use that all the time. Whenever you have a string, you need to go all the way through the string, your loop will always look like this. If you decide you don't like a variable named I, you want to change it to a variable named J or a variable named P, that's fine. But the logic will remain the same. Now, if you're looking for things that match something else, index of is often a very, very, very good solution for it. As we see, it's a very good solution for what we're doing here. 3 separate problems, 3 nearly identical solutions. Couldn't we make this generic and say static void print vowels in set string s string set? Take this exact same code, but instead of saying map, say set. Like that. And then could we gut all these other ones and say driver dot print vowels in set, passing it s and passing it map? Print consonants, same thing. Print vowels 2, same thing. We can, well, whatever. Print non-vowels, same thing. Actually, print non-vowels won't quite be the same thing. Well, it would have been, but we would have had to say literally every character that's not a vowel. All the consonants, all the numbers, all the question marks, everything. But we wrote one generic method here, print vowels in set, that takes a string as a parameter, as well as a set of characters. And we're going to go through, and for every single character in our string S that is a member of that set, we'll print it. So print digits, we pass it the set of digits. Print consonants, we pass it the set of consonants. Print vowels, we pass it the set of vowels. So now I can say print digits, driver dot print consonants, driver dot print vowels. And here I'll put a little carriage return in between those so we can actually see where one starts and one ends. So the first one should print out all the digits, 1, 2, 3. Then we should have an empty space. Next one should print out all the consonants, that is H, L, L. Empty space. Next one should print out just the vowels, E, O. And all of those guys are defined in terms of this generic method we wrote called print vowels in set, that each of these guys calls, passing in a different set of characters. 1, 2, 3, H, L, L, E, O. Does that make sense? How we recognized the pattern and made a generic tool, and now this method can be used for printing out one character at a time. All the characters in S that are members of this set, whatever is in set. All right, questions about that? All right, so let's look at the easy question from the homework. So we did 1, 2, and 3, right? Print vowels, print consonants, print digits. And we just proved that all three of those questions were basically the same question. Okay? Now, I know I asked this before. Nobody used index of for solving the problem, did they? In your homework? I harped on it. Any of you think about using index of for the homework? And it just didn't happen.
Didn't know how, where. I wasn't sure.
Okay, well, does it make sense now?
Yeah. After the fact.
Well, that's always the case. That's what makes my job fun. People spend 12 hours on a homework assignment and come in and say, look, it takes 30 seconds. It's 4 lines of code. Here. Gotta make sure my tires don't get slashed down the parking lot. All right, so this last one obviously was the easy question, right? How many of you got 1, 2, and 3 but did not get 4? How many of you didn't get any of them? Ish. All right, so let's talk about number 4. Number 4 was definitely the most challenging. So it's a method called process expression. This method should take a string following this format. So I kind of gave a scientific-y type of thing for the format. That's an integer. Optionally, that's what these square brackets mean. That's an optional. Optionally followed by an operator followed by an integer, 0 or more times. Okay? I gave you some examples of those. So for instance, you could have a string containing just an integer, or a string containing an integer followed by an operator followed by an integer, or a string containing an integer followed by an operator followed by an integer followed by an operator followed by an integer, or an integer followed by an operator followed by an integer, so on and so forth. Make sense? Okay. So that's the format that our string is in. Your method should then process this expression and return the result as an integer. You must solve this problem using only tools that were taught thus far in the class. Now, if you have the string 125, this should boil down to the integer 125. If you have the string 125 plus 7, this should boil down to the int 132. If you have the string 125 plus 7 minus 2, this should boil down to the int 130. 125 times 2 should boil down to 250. 10 divided by 3 should boil down to 3. Truncated, integer math. Okay? You only had to make this work left to right. So you didn't have to worry about order of operations. All right. So, let's go and solve this. Let's get rid of all this extra riffraff. Let's make this work on the easy case first. I have a string here, and I need that string to be an integer, correct? How do I make a string? I mean, because we're humans, we can look at this, we can say, oh, this is just a number. No operators, we don't have a number followed by an operator followed by another number, we have just a number. So I'm saying let's solve the simple problem. Let's solve the problem of turning a string containing a number into an actual number. How do we do that using only what we've learned in here so far? How could I take the string 125 and have this boil down to the int 125? That is to say that if we took s, if I said system.out.println s concatenated with 3, sorry, s plus 3, I would get what? 125, 3. But if I said system.out.println 125 plus 3, I would get 128. See the difference? So I need to convert s into its integer equivalent, not treat it as a string. That way we can actually do math on it. All right, so we want to write a method that converts a string just call this guy string to int. That takes a string as a parameter and returns the integer version of that string. How would we do that using only what we've learned so far in this class? In the whole course, not just today. And hopefully none of you happy Googlers used a tool that we didn't introduce in the class that I will show you after we do this to make it worlds easier. You can only use tools that are in our toolbox from what we've done this course.
You should have it checked to make sure the string doesn't have anything besides.
I promise you it does for right now. But I agree. But for right now, we can assume that S only has digits. Remember back to the first day of class? Talked about how human beings are such good problem solvers that we forget how we solve problems. How many of you had, you may even learn this before first grade. We all had first grade math, right? Second grade math? Possibly even kindergarten? When did you learn how to count? When did counting happen? Oh. Oh, so it may even been before kindergarten I'm talking about.
Yeah.
Ooh. So a kindergartner could have done this. Now, how many people got this question working? One and a quarter people? All right. So, in order to get this question working, you have to be able to, at some level, convert a string to an int. How? Okay. Say that again. You said the integer length is the same as the number of characters in the string? Let me ask it this way. We, as a human being, we can look at this string, the string 125, and we know that that is equivalent to the integer 125, right? We can do that solution in our head. What I'm asking you to do is to slow down and tell me how you solve that. We have to understand numbers. What is 125? Well, isn't it a 5 plus a 20 plus 100? Isn't that the math way of looking at it? Or you said 125 times. Is that what you said?
Yeah.
Okay. I guess that's fair enough. So if we were doing a math problem here, this 5 right here is in the ones place. This is in the tens place. This is in the hundreds place. Right? Ones place, 1 times 10 is tens place, times 10 is hundreds place. So, how would I write a loop that starts at the end of a string? Let's say I wanted to take a string, and let's say I wanted this here. I'll rename the method just for time being. Print backwards. And we'll have a return of a void for right now. So I need to notice the pattern of walking a string backwards. Well, the pattern of walking a string forwards is the for loop we've been using all over the place, right? Well, now we need that for loop that walks a string from the end towards the beginning. What's that for loop look like? For int I is equal to what? What's the last legal bucket in S? S.length minus 1. So that's that pattern. We're going to keep going. What's the first legal bucket in S? 0. We're going to keep going as long as I is greater than or equal to 0, because 0 is a legal bucket. Each time through, we'll subtract 1 from I. So won't this method print out whatever S is in reverse, 1 character per line? This for loop takes I on a journey from the last legal bucket in S to the first legal bucket in S, subtracting 1 each time. What am I going to do each time? I'm going to print out the character at bucket I in S. This will print out the last character, second to last character, third from last character, all the way up to the very first character. So if I were to say driver dot print backwards S, this is going to print out 521, because that's 125 backwards, right? So there's a pattern. So start collecting these patterns in your toolbox. This kind of goes back to, it reminds me of high school math classes are a decent example, where I remember my teachers like forcing me to memorize these postulates and theorems and all these things. And I always thought it was stupid. Like, oh, why am I memorizing all this stuff? But then the teacher would throw this crap at you like, well, you know, once you understand this stuff, you'll be able to infer whatever the theorem is or the postulate is based on your understanding of the math. You won't have to memorize it. And I always thought he was full of it. The reality is memorizing things initially so you can use them makes some sense, but eventually you don't have to remember that this is the pattern from walking a string backwards. How do you walk a string backwards? Start off at the end of it, go to the beginning of it, subtract 1 each time. So once we understand the nature of strings, writing this loop shouldn't be something you're pulling out of memory. The thing that you have in memory is the syntax for a for loop. The pattern for walking a string backwards is something we're using as somewhat of a crutch right now. Kind of make sense? Okay. So this prints whatever I pass it backwards. Now, we're trying to write string to int. Now, if this is my string, and I'm going to start at the last bucket in it and work towards the first bucket in it, each one of these guys is a place. This is the ones place, tens place, hundreds place, thousands place, 10,000s place. That make sense? That's base 10 numbers. Been using those for years. We're so good at it, we forgot how they work. So I'm going to say int place is equal to 1. So that'll be the first time through. We're in the ones place. We'll multiply it by 10 each time. And what do we want to do? We want to take whatever number is in that place and get the int version of that. So I can write a method called char to int. This guy might take a char c as a parameter. And if c is equivalent to a 0, return 0. Else, if c is equivalent to a 1, return 1. Else, if it's a 2, 9, 2, 2, 3, all right, easy, right? If I pass it the char 0, return the int 0. If I pass it the char 1, return the int 1. If I pass it the char 2, return the int 2. If I pass it the char 3, return the int 3. Make sense? Now, why is this screaming at me? It's going to tell me that this method must return a value. This method must return a result of type int. Well, I'm returning something here, I'm returning something here, I'm returning something here, I'm returning something here. Doesn't this guy return an int? The problem is, these are all if statements. And you only get inside the if the Boolean expression is true. So while we know, as long as we pass this guy chars that are in the range of 0 to 9, that he will always return something, according to Java, there is a possibility that we could go through this whole question, this whole line of questioning, and never actually return a value. So somewhere in here, we have to throw in like an else return -1 or something like that. That's our catch-all. If something bad happens, return a -1. But since it's in an else, this is guaranteed to happen eventually. If the method doesn't previously end, methods end immediately when we hit a return statement. So if we return 5, this method's over, and a 5 comes shooting out the back here. Comes shooting out as the return value of this. We would not try to see if it's a 6 later on. If it's a 5, it's a 5, we'll return a 5. Okay, so we'll only hit at most one of these return statements. But in order for Java to be happy, we must have a statement that's guaranteed to be reachable. So now Java's not complaining because we have advertised that we're returning an int. And in fact, this code here is guaranteed to return an int. In our worst case, we'll hit this else and we'll return a -1 if we're still kicking then. Does that make sense? If we tell Java we're going to return a value, we must return a value. Okay. But you know what? Just a crappy solution. Surely we can come up with a better solution for char to int than that.
You're going to tell us to use index L.
I very well might. Actually, I won't.
Oh.
Here, I'll give you an interesting challenge. Solve this without Can I do that? Is that fair? No, not fair yet. Solve this using index of. So here, take 5 minutes, try to write this method in terms of index of. Just this method right here, this small one. Not grading it, no pressure, just try to think through that problem using only the tricks I've shown you today. About 30 more seconds. All right. So let's take a look at this. Anybody have a good suggestion of how we can solve this using index of? Will that do it? Index of returns the position in the calling string where C first occurs. Let's say C was the character 0. What position in this string is 0? The first occurrence of the character 0 is at index 0. First occurrence of character 1 is at index 1. Index 2. Index 3. 4. 5. 6. So on and so forth. What if I passed in a Q? This would boil down to a -1, wouldn't it? Question. Is it legal to call the index of method like this? Don't I need to create a string map, put this dude in that string, and then say map dot? Do I need to do that instead? What's map? What's this guy? It's a variable. Variable that holds what? Variable that holds, I think even last time I told you, for right now we'll fake it and pretend like it holds a string. It actually holds a memory address which points to the actual string. We'll talk about that plenty. Okay, so map is a variable. What do we need variables for? Keep them because we have to use them later, right? Do I need to use this value more than once inside this method? My method's one line long. I hope not, right? Question is, right here, when I say map.indexOf, at runtime, this variable right here, map, is going to get resolved. And what will it resolve to? It'll resolve to its value. That's the guy that's actually calling index of. The value stored within map. So this is perfectly acceptable. In fact, it's more efficient. Why store this string inside of a variable and use the variable here when at runtime that variable is just going to get resolved to the value that's inside of it? At runtime, this is what's getting called anyways. Index of is a instance method in the string class. How do we call instance methods? Using an instance of the class in which the method was defined. So we need an instance of the string class. Is this guy a string? He absolutely is. He's not wearing any clothes. Other strings we've had hidden inside of variables. They had a suit on, pretending to not be strings. This guy is au naturel. He is a string. All right? So we're having this string call his index of method, passing it a char, and what will come out of this? It'll come out an integer. 0 if it's at bucket 0, 1 if it's at bucket 1, 2 if it's at bucket 2, or -1 if we did not find it. So this code right here will boil down to the character, or the integer equivalent of a character. That makes sense? All right, well, so now we're back down here. String to int. We're walking our string backwards. Right now we're just printing out the character. What do we want to do instead? Well, we're going to have a sum. Start this off at 0. Why is that? Well, if I come back up here, let's just do this math again. Let's say I had a sum that was equal to 0 initially. And I hit the 5. The 5 is in the ones place, right? So far I have 5 times 1, which is 5. Then I hit the 2. The 2 is in the tens place. 2 times 10 is what? 20. 20 plus 5 is 25. Now I'm at the 1. Now I'm at the hundreds place. 1 times 100 is 100. 100 plus 25 is 125. So I'm going to use that sum to accumulate my answer. So what are we going to do? We are going to say sum is equal to whatever sum is currently equal to plus. And what are we going to add to it? We're going to add the character we're currently looking at, which is s dot char at I, that guy, but I don't want the character. I want the int version of that character. So I'm going to say driver dot char to int of that char. That is, give me the integer version of the char from the string. That's what that highlighted line says to do. It says, look at the current character, pass it as an input into my char to int method, and this guy will ultimately boil down to the integer version of that char. And once I have the integer version of that char, what am I going to do with it? Well, I'm going to multiply it by place and then add the product to our running total. And each time through in our for loop, I'm going to say place is equal to place times 10. We'll start at the ones place, then the tens place, then the hundreds place, then the thousands place, so on and so forth. So as we move to the left, we start at the end of our string, move towards the front of the string, and each time, place starts off at 1. Now it's 10. Now it's 100. Now it's 1,000, so on and so forth. That makes sense? So after this loop is done, after we've gone through all the characters in my string, doing all my multiplication and addition, in the end, I'll just return sum, which should be the integer version of my string. Okay, and I need to make sure I change string to int to return an int. It originally did, but then we changed it back to void when we had it print backwards or something. Okay, so this is what string to int does. So we'll test it up here. First thing we'll do is we'll do system.out.println s plus s+3, which should give us 1253. We've seen that, right? Then we'll say system.out.println driver.string to int s +3. So if this guy works the way we think he's working, this should boil down to the integer 125. So this line should print out 128, proving we can do math with that number. Okay, so this should print out two things. 1253, adding 3 to the string version 125, We're just concatenating onto the end. And then we're proving that we were able to extract the integer equivalent out and do math with it. There's 1253 and there's 128. And we could even simplify this. Isn't this a pretty short method? The whole contents of that method is this stuff right here. Can't I actually just steal that? Get rid of that method. All that method was doing is calling that line anyways. So if I'm looking at a 3, this will boil down to the bucket 3, the int 3. So rather than throwing it in a separate method, why not just use the method directly? So s.charat will be a character representation of a number, a digit, and using index of in line here will allow me to extract the int version of that char. And we'll see this works identically. It works identically because it is identical. I'm just not calling a method which calls a method, I'm just calling the method itself. Okay, so this is step 1. I now have a method that if I passed it a string that contained numbers, it would give me the integer version of those numbers. Correct? This is a good tool for solving this problem. All right. Now, keep in mind that our function that we take in might look like that. Our expression. We might have the string containing 125 plus a 27. So we need to write some code that builds these tokens. I need to go through and I need to get the 125. Then I need to get this operator. Then I need to get this 27. I need to be able to process these strings one number or operator at a time. That makes sense? Okay, so let's start off by writing a method here. Static we'll make it void for right now. Let's call this guy print tokens. And what we want print tokens to do is, if we were to pass it a string that looks like this, it should print out 125 on one line, then it should print out a plus sign on another line, then it should print out a 27 on another line. So we're saying this is a token, this is a token, and this is a token. Make sense? So that's what we want it to accomplish. How are we going to do that? If I'm looking at this string, what parts of that string am I ignoring? What part of that string am I not interested in?
The white space.
White space. Spaces in there. Not interested in spaces. Would you agree that spaces are what separates the parts I am interested in? Okay, so I want to build up new strings as long as I'm hitting something that's not a space.
What if someone puts it in without spaces?
Huh?
Yeah, if someone puts it in without spaces.
Let's see if that's legal. All of mine had a space in it. Yeah, so all of them have to have a space and a space.
Okay.
But I mean, you're right. If we had to have spaces, then we'd have to treat it differently, and we'll actually do them both. It's an interesting question. But let's start off assuming we have spaces. Okay? So, what we're going to do is we're going to create a string called cur token. We'll start this guy off with the empty string. I haven't found any tokens yet. Okay? So right off the bat, I need to go through every character in S. Correct? All right, I is equal to 0. I is less than S dot length. I plus plus. That look familiar to you? That's our go through every character in a string loop. Okay. Now, as we're going through the character of the string, as I'm walking through here, if the current character is not white space, I'm going to do what? I'm going to add it to cur token. If s dot charat I is not equal to a space, then what am I going to do? Well, I'm going to say cur token is equal to whatever cur token is currently equal to concatenated with s dot charat I. Tack that guy on. So as I walk through here, I'll tack on the 1, then I'll tack on the 2, then I'll tack on the 5 for 125. That make sense? As soon as I hit white space, I'll be in this else. If it's not white space, do this. If it is white space, what does that mean? It means cur token currently holds a full token because I just hit white space between tokens. Does that make sense? So what do I do with tokens? I print them. In this, for our example here, system.out.println cur token. So we'll print it out. Then we'll set cur token equal to the empty string. Empty it out. And then let it keep trucking. We'll call this guy driver print tokens on S. What will it print out? So here's my method. If the input to that method was this guy, what would the output be? Okay. Who agrees with her? We'll see how the voter turnout is. Who disagrees with her? What you said the output is what it should be, but in this case it's not. It's close. So this is an important exercise. Take the next, let's say, 3 minutes. Assuming this was your input, assuming that's what comes in as S here, trace through this code by hand and understand what the actual output is. Literally walk through this code. You know, there's only, 3, 4, 5, 6, 7, 8. 8 times you have to go through this loop. It's not like I'm asking you to perform brain surgery. All right? So trace through it and write on your piece of paper every single time something should print. And keep track of what the current value of cur token is. And you'll see where the problem is. Okay, so what's the output? Don't all speak at once. What's the first token it outputs? 125. What's the second token it outputs? Plus. What's the third token it outputs? Does it print out the 27? I said trace it by hand. Every little piece. Does it print out the 27? Why didn't that 27 print out? If this is the code, as it's currently written, why does the 27 not print out? If you trace this by hand, like I asked you to, it should be clear why the 27 is not printing out. Write down on paper, cur token, start it off as the empty string, walk through your string one character at a time. Am I looking at the space? No. Tack on 1 onto cur token, then tack on 2 onto cur token, then tack on 5 onto cur token. Ah, I just hit a space, so I'm in this else. Print out whatever cur token currently holds, then make cur token be nothing. Loop back up, keep going. Next time through, what do? We read in the plus. Well, is that not equal to a space? That's true. So cur token is equal to whatever cur token is currently equal to. What's it currently equal to? The empty string, concatenated with a plus. So now we have the string representation of a plus. Okay? Then we hit a space. Is it true that a space is not a space? Space is a space. So we go to the else. We print out the current contents of cur token. What's the current contents of cur token? Space. Plus sign. Current contents of cur token is plus sign. So we print out plus sign, set cur token back to the empty string. Spin back up. We read in the 2. Is it true that 2 is not a space? That's true, so cur token is equal to whatever cur token is currently equal to, which is what? Empty string concatenated with a 2. Okay? Spin back up. Read in the 7.
Oh.
Is it true that a 7 is not equal to a space? It is. So we'll say cur token is equal to whatever cur token is currently equal to, which is a what? No, it's currently a 2. Currently a 2. Concatenated with a 7. So now cur token is now 27. Spin back up. We hit the end of the string, which makes us fall out of our for loop. I'm right there. Where is the 27?
Still in cur token, but we didn't print it.
Stuck in cur token. We didn't print it. I can say system.out.println cur token here, and now it'll print out. I built it up inside of cur token, but my else, which only fires when we hit a space, never fired for the 27 because I didn't hit a following space. I could have made it work by throwing a space in there. That make sense? Okay. So, given our current syntax here, pretending that the spaces are important from the algorithm I gave, or from the grammar for the language I gave, we have a token followed by space, operator, space, token. So I can add more things on here, right? I can say minus 85 times 13 divided by 2. left to right. Order of operations make this a lot more difficult. We don't have the skills to do it. Okay, so will this print out all these now? Or will it just print out the 125, the plus, and the 27? Should print out all of them. 125 plus 27 minus 85 times 13 divided by 2. Because the only problem we were running into is that last token was getting stuck because we never hit a space after it. Okay? So now we have a method that can go through and it can process an expression like this in terms of its tokens. Good.
And no, it wasn't a question, I was just thinking of myself.
Okay. Well, now we want to do math, correct?
Well, we have the tokens as strings and we have strings int, so we just plug them in. Yeah?
Yeah, for the most part. But now we need to walk it. We know that if we hit one token, if we only hit one token, we know it's a number. We know that if we hit the next token, we hit another token, we know it's an operator. Then it's a number, then it's an operator, then it's a number, then it's an operator, then it's a number, then it's an operator. So there's a pattern. We know what will be a number and what will not. Okay? So let's call this guy process expression. Is that what I told you to call it in the homework? Okay, it'll take a string in as a parameter. Okay, and I'm going to create a int called answer here. And we'll start off at 0, but it doesn't really matter. We'll also create an int called num tokens. We'll start this guy off at 0. Okay, what does this code here do? This code goes through our string, collects tokens, and right now it prints out that token, and then goes and gets ready to collect the next one. But I don't want to print the token. Instead, I know that when I'm here, cur token holds the current token we just collected. Now we need to do something with it. Okay? If num tokens is equal to 0, that is, if this is the very first token that I've collected, then I know it's a number. Correct? And if it's a number, what do I want to do with it? I just want to stick it into answer as my starting point. So I'm going to say answer is equal to driver dot string to int per token. That make sense? So if this is my very first token, and here I'll even show you what I'm going to do here at the end, num tokens plus plus. Every single time I finish a token, I'll increment tokens. So num tokens will only be 0 the very first time. I defined it up here because I have not found any tokens yet. As I find tokens, I want to recognize that, oh, this is the very first token I found. Therefore, to get the ball rolling, I'm going to set answer equal to the integer version of that token. Don't need to do any math for him. That makes sense? Else. I know I'm looking at a token. So if I'm in this else, I am not looking at the first token. So I'm looking at something after the first token. Right? This is token 1. This is token 2. This is token 3. This is token 4. This is token 5. This is token 6. This is token 7. This is token 8. This is token 9. Any pattern you're seeing as to where the operator tokens are? even tokens. Operator tokens are in even tokens. Now, when I get to the operator token, so the first operator token I'll run into, num tokens will currently be equal to 1, correct? Because I have not incremented it until the end. It does not become 2 until the end of this guy. So if num tokens is odd, it's currently odd, I know I'm looking at an operator because it's about to become even. How do I say else if num tokens is odd? How do I write that code? Definitely modulus. So num tokens mod what? What's an odd number? Divisible by what equally? 2. So an odd number is a number that 2 does not go into an even number of times. So num tokens mod 2 equal 1. What are the possible results of taking any positive number and modding it by 2? And if you're taking some notes, you might find this helpful in this week's homework. Hint, hint. And remember that next week when I make fun of you for not remembering when I said hint, hint there. If I take any positive number and I mod it by 2, what are the possible results I can get? Pick your favorite number. Any number bigger than 0 but positive. Yeah, any number bigger than 0. Pick your favorite number bigger than 0. Doesn't matter how big it is. Okay, mod it by 2. What are your possible results? 0 or? So I promise you, in my head right now, I'm thinking of a number greater than 0. A whole number greater than 0. I don't have to tell you what that number is for you to tell me what the possible results of taking whatever number's in my head and modding it by 2. What does it mean to mod something by 2? Third grade math, remember? So far we've done kindergarten math, pre-K, right? Pre-K math today. And now we're doing third grade math. High-end stuff. What is modulus? Does long division, right? So modulus gives us the remainder of integer division. So if I divide something by 2, what are the possible remainders I could have? 0 or 1. What about 2? Could I have 2 as a remainder? If I divide something by 2, can I have 2 as a remainder? Sure I can. If I did bad division. If I have 2 as a remainder, I divided something by 2, that meant 2 went in another time, right? So when I divide something by any positive number n, the possible remainders are 0 to n minus 1. Modding by 2, 0 or 1. Modding by 3, 0, 1, 2. Modding by 4, 0, 1, 2, 3. Make sense? The last 30 seconds to what I've been talking about, you will find extremely helpful on your homework assignment this coming week. Hint, hint, and all that jazz. Okay, so if num token mod 2 is equal to 1, that means it did have a remainder, which means that 2 did not go into it evenly, which means that num tokens is currently odd. That's what this says right here, right? If num tokens is odd, that's what I have highlighted. That's what that guy says. So if num tokens is odd, I am looking at an operator. right? What do I do if I'm looking at an operator? Well, let's just walk through this by hand. So far, I've read in the 125, stored that inside of answer, right? Then I've read in my operator, plus sign. Do I do anything? Can I do math yet? I don't have all the inputs. Plus requires two things. Can't do the math until I get my next number. So what do? I need to remember the plus sign. So I need to remember the current operator we're dealing with. Okay? So what I'm going to do, are all of our operators single digits? Single characters? Right? Plus is a single character, minus is a single character, times is a single character. So I'm going to create a char called corrupt. And initially I'll just set that equal to a question mark just to get the ball rolling. We have no operator in there. Okay, so corrupt starts off as the char question mark. This is before I get into the loop or anything. So if I'm looking at an operator, I'm going to set corrupt equal to, now how do I get the char version of the op stored inside of cur token? Cur token is a string, correct? Operators have one character to them. How do I get the char version of the operator currently stored inside of cur op as a string? Char at what? Char at's how I get a character out of cur op. Which character do I want to get out of cur op? If I'm looking at an operator, how many characters are in cur op? 1. Which means is that bucket what? 0. So cur op will equal cur token dot char at 0. That'll get me my current operator. Else, I'm looking at a number that is not the first number. We treated the first number as a special case to get the ball rolling. So if I'm looking at a number that is not it's not our first number, that means that currently I have 125 in answer, I have plus in cur op, and I have 27 as a string inside of cur token. So I need to get the integer version of 27, and then I want to take whatever's in answer, perform this operation on it with this guy. Correct? So I'm going to write another method. Have it return an int, perform op. This guy will take in a char op, an int a, and an int b. So he'll take in our two inputs, and we'll say if op is equal to plus, return a plus b. Else if op is equal to minus, return a minus b. Else if op is equal to times, return a times b. Else if op is equal to divide, return a divided by b. And again, it's screaming at us because we didn't actually return a value. So we could actually just throw this inside the else. If it's not a plus, it's not a minus, it's not a times, it must be a divide. Those are the only operators we support. So we don't actually have to check to see if it's a divide. We can just say, if it's a plus, do this. If it's a minus, do this. If it's a times, do this. Otherwise, has to be a divide. Return this. All right, so that's what this method does. Perform op takes in an operator and two numbers, and whatever depending on what the operator is, it does that math to those numbers. Right? Nothing complicated about this. If I passed in a plus and a 1 for A and a 2 for B, it would boil down to a 3. 1 plus 2 is 3, right here. All right, so that's perform op. So then down here in process expression, if I'm looking at a number that is not the first number, I know that I already have something in answer. Answer is my A. I know I have something in cur op, that's my op, and I know that my B is the integer version of whatever's in cur token. So I'm going to say answer is equal to driver dot perform op on cur op, whatever answer currently is, and driver dot string to int of cur token. That make sense? So I'm going to overwrite my answer, which is my running total here, this guy. I'm going to overwrite that guy with whatever perform op returns on our current operator, the current value for answer for A, and the integer version of our current token. So the first time through, we would have called, for our current example, we would have called perform op on 125. Well, the first value we would have passed is the plus sign, the char plus. Then we would pass the answer, which is 125. Then we would have passed it the integer version of cur token, which is 27. So that should boil down to 152. And what did we do with the 152? We stored it back inside answer. So now answer is 152. Next time through, what do? Well, we read in the minus. That's an op. Overwrite the plus op with the minus op. Fine. Then we read in the 85. What do? We call perform op, passing it minus, passing it the current value of answer, which is 152, the result of our previous perform op, and passing it 85. And that should do it. So if we look at our examples, this should work on 125 plus 7. So let's use a couple of these. So we'll do it just on 125. We're going to say process expression is going to boil down to an int. So at the very end of this guy, we're going to return answer. So after all the loop, after we've gone through our entire string, got all the tokens, and done all the math, the very end answer should hold our cumulative answer based on all the math it asks us to do. So we'll start off with S being 125, and we will print out system.out.println driver dot process expression S. So first time, this should print out 125. Row. 125. You just print out a 0, which is the current version of answer, so I must not have.
It's probably because we still have the system out println cur token.
No, I took that out.
Oh, I didn't know.
Let me just walk this real quick. So this says go through all the characters in S, so S should look like 125. Fine. So we'll go through there. If I'm not looking at a space, start collecting tokens. So we'll collect the 1, 2, 5. Oh, why is it a 0? It's a 0 for the exact same reason as it didn't print out the 27 previously. Never hit the white space.
Mine gave me something completely random. So can you just scroll down slowly so I can?
Well, let me finish going through this and I'll leave the code up when we take our break.
Alright.
That way you can look at it. So what we need to do down here is ask a question before we just return answer. If answer is currently equal to 0, that means we have something stuck inside of cur token. Then we'll say answer is equal to driver dot string to int cur token. So before we just return our answer, we need to make sure we don't have that one last guy stuck inside of cur token because we never hit a space. In our current example, we have a string that just holds 1, 2, 5. And with that, we would have built up our first token, cur token equals cur token plus s.char at I, but I would have never hit something that was a space, so I would have never gotten into this else. Therefore, at the very end here, we still have, so this question says, is something still stuck in cur token? That's what that asks. If there is, go ahead and load that into answer, because the only time that would occur is when? As far as we know right now, it only occurs in this situation. But would it also occur in that situation? It would, wouldn't it? Would it also occur in that situation? Every single time we might have a dangling corrupt. Correct? In fact, let me ask you this. Are we guaranteed to always have a dangling corrupt? I'm sorry, a dangling cur token. Given the syntax, given how this thing works, what the possible inputs are, I'm guaranteed to always have my very last token be left over. Does that make sense? How do I fix that? Well, we can write a lot of extra code, go through here and basically duplicate everything that's in the else. Correct? I can do that because I'm going to need to do this math later on, won't I? So I might need to do this math down here. But I actually could get rid of this and fix the entire problem with one line of code. Why does this guy have an extra cur token at the end? Why does the cur token get locked in there? What's the reason? This guy is stuck. Why? There's no space after him. What if I just added a space? Not here. No, my users have to pass the thing in like that. That's the legal input. But what if I wanted to just tack an extra space onto the end? Could I do this? Can I just shortcut this? Can I manipulate the input a little bit so that it works now for my output? Let's go back to just the 125. There's my 125. 125 plus 3. There's my 128. Divided by 2. There's my 64. Minus 4. There's my 60. Plus 3,000. There's my 3,060. Divided by 2741. Is that correct? How many times does 2,000 blah 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 go into 3060? One time. There'll be a remainder, but this is integer division. That make sense? So this will solve the problem. And there's some different ways you could have done it. Most of you probably did it a lot more verbosely than this. A lot more code, would be my guess. We really tried to leverage the index of. So what was difficult about this? Was there any individual part of this that was hard? It was a daunting assignment, correct? But now that you've seen the solution, was any individual part of the solution ridiculously difficult? Or was putting all those pieces together in the right order the hard part? So something I'll say now, and I'll say it a lot more times, in the other class you'll have with me as well. All hard programs are made up of a bunch of easy parts. I guarantee what you know right now about Java or in C++ are basically look the same. You could go look at the source code for Windows 8, and you pretty much know what's going on. At any point, they showed you a random page of Windows 8, you know what you'd see? You'd see loops, you'd see variables being defined, ints, you'd see some strings. All things that you're familiar with. But they're putting them together in a couple 100 million lines of code in a bunch of interesting ways. And that's where the complexity comes from. So all hard problems are made up of a bunch of easy parts. So this was not a ridiculously difficult problem, but just difficult enough that the complexity went off the charts for us because we had to really keep our mind wrapped around the idea of, oh, here's an easy part. Here's another easy part. How do I make these two parts work together to produce this part? How do I make this part work together with this guy to make this part? So you start thinking about building things out of widgets. And that's why we wrote these things in methods. All right. So questions about that. I'll leave my code up here over our break in case somebody wants to come up and copy something down or check to see what's going on. Oh, so you got it?
Yeah.
Okay.
That's actually that's how I messed up on 3 of my problems in my calculus test this week. I happened to drop minus signs.
Pay attention to the details. All right, so let's take about a 20-minute break, reboot our brains a little bit. I'll get this uploaded.